On your mark, get set, let's go. So we have homework number 3, question number 1. Again, we're not writing a proof, we're not writing a proof, we're not writing a proof. We are simply trying to figure out what in the world the values of x and y are, so we need to kind of develop a plan. We could go to the triangle first. So we have an angle, we have an angle, we have an angle. We know they have to add to 180, but oh, look at this. We have an angle, our variable x and a variable y. That's not going to work. One equation, two variables, not going to be good. But lo and behold, what do we have? We have three angles here that form a line. Bilinear pair Paschen, of course, definition of supplementary. Those have to add to 180. That's where I'm starting. So 25x minus 5. And we're going to add 10x plus 5. And then we're going to add 30x. Those three angles, 1, 2, 3, 1, 2, 3, 1, 2, 3. That has to equal 180 degrees on the sum. Now, there's a couple different reasons for this. Of course, we can quote the linear pair postulate. That's a big one. Also, the definition of supplementary is another biggie. But those two ideas combined definitely gave us this equation. Now let's solve it. 25x's, 10x's, 30x's, that's going to give us 65x's. 30, 55, 65. Negative 5 plus 5 cancel, and so that's going to be directly equal to 180 degrees. If we have 65x is equal to 180 degrees, then if we divide both sides by 65, we end up with a x value, and I should say approximate x value, of 2.769 2. Let's go 4 decimals. Let's maintain a level of accuracy here, shall we? Um, so quickly double check our works. So 25, 35, 65. Fives are gone. We're good to go. Let's move on to the y value. Now this one we are going to use a we are going to go ahead and use a triangle sum theorem. But now we actually have a value for x, so at some point that'll be substituted. But again, it's not proof, so we're not too careful showing every single one of our steps. But I do know if I take angle, or the angle is 100 degrees, I add 100y minus 45, um, minus 45. And then I add 10, and instead of x, I'll go ahead and just write in 2.7692 plus 5. That should equal 180 degrees. Now I'll probably be a little more careful with a calculator this time around, but in the end I only see one y value, so that's 100y. And then if I add all our other pieces together, that'd be 100. Then subtract off 45, add 10. Excuse me, 10 times 2.7692, and then add 5. That leaves me with a final total value of 87.692, and that's equal to 180 degrees. So subtract off that crazy looking thing. So 100y is equivalent to, look at that y, I kind of got it out of control, didn't it? 100 y is equal to 92.308. Divide that by 100, and the y value is 0.2, or excuse me, the y value is equal to 0.9231, approximate, of course, because I rounded. Okay? It's not pretty answers, but you know what? That's okay. They're answers nevertheless. All right. So, moving on. Okay, so excuse me. So we want to find the length of the segment with a given endpoint, so it may help to graph. So again, I could graph it. I'm not going to. We know the distance form at this point, so I'm going to go ahead and use it. So uh, the distance AB is defined to be the absolute value of the difference in the x's squared plus the difference in the y's squared. So if I'm looking at the difference in my x's, well, I start at -5 and going to -26. That's going to be a difference of 21. So if I square 21, so if I square 21, I'll get 441. Okay, and then we have to add the difference in the y's. Well, I started at 10, ended 10, guys. That's a difference of 0. That's a difference of 0. So I'm just looking for the square root of 441. Wait a minute. If 21 squared and take the square roots, that's going to be just 21 again. So 21 is my final answer. Yoink. Okay, midpoint. Well, that's going to be another synonymous term for bisector. So we're looking for the middle. Now, again, a graph would really help to kind of visualize what's going on. But if I'm looking for the middle, let's just look for the middle. Um, if my x's start and end at 6, the middle would be at 6 also, wouldn't it? I mean, if we start at 6, end at 6, right in between 6 and 6, that's going to be 6. If I start at -8, end at 12, well, I can find that average. -8 plus 12 divided by 2. -8 plus 12 would be 4 divided by 2. Oh, no, excuse me, that's wrong. No, we're good. I don't know what I was thinking. Yeah, we're finding the average. And again, the average is found by adding the two values and dividing by how many values there are. So yes, I'm sorry. Temporarily kind of brain freeze. -8 plus 12 is 4. 4 divided by 2 is 2. That's the missing value. My midpoint should be at 6.2. And moving on to this one. Okay, a student explained that 3 points are needed to form a plane. However, his teachers pointed out that there is a major component missing. That sounds like something I do. That just any 3 points are not define a plane. Well, what is the missing? What is missing, and why is that component so vital? So, guys, if I just pick 3 points, is that guaranteed to be a plane? I think not. If I can pick 3 points at random and make them so it does not necessarily define a plane, that's what the student's missing. Oh, look at that. 1, 2, 3 points. Although they may be a plane, which plane would it be? They are planar. We established that in the previous homework, but there's no plane that's definite. That's what this is missing. I want to pick 3 points and actually know exactly where that plane is. Well, to do that, the key phrase has to be non-collinear. Like if I pick all 3 on the same line, that's what this guy is. That's no good. I don't want that. But if I pick 1, 2 points, they can't help be collinear. But if I pick a third point that's not, that's going to define my second dimension, the wideness, so to speak, of the plane. That's going to be how we can actually now define, ooh, I missed, define multiple points. That's going to define my plane. So the key phrase here is non-collinear points. Okay? So the 3 points that I have to pick are non-collinear. Otherwise, I'll just end up with a line, not a second dimension of a plane. Explain why circles are so vital to the bisection below. Excuse me. Cite specific properties of circles that make the bisection possible. Well, guys, this all goes down to the idea of a radius. The darkened arcs are the purple darkened arcs are this arcs you actually need, but remember, they're part of bigger circles. The whole idea here is if I choose a radius, say between A, and the end of the circle, um, that radius is going to be the same for the entire circle. Like, so that radius that I've chosen is actually what's defining the circle. So think about what it means to be a circle. Any point right here that lies in the circumference of the circle is exactly the same distance from A as all the other ones. So right now, this point right here is the same distance from A as this point is right here, as this point is right here. Well, to be a bisector means that the point is exactly the same distance as both endpoints. So what if I take the same radius and I shift it over to B and make another circle? Make this circle. Well, the same property of the circle has to be true. So if I pick a point right here on the circumference, that's the same distance as to B as this guy right here, as this guy right here. So if I look at where they intersect, if I look at where they cross, clone. So if I look at where they intersect, that means this point right here lies on both radii of the circle. Well, radius by definition is the same, right? So if this point is on both radii, it has to be the same distance as the endpoints. In fact, anywhere they intersect should do that. So the same should be true for the one up here. This point lies on both circles, therefore has the same radii back to the center. That's why it's a bisector, because of the radius distances, nothing else. The circles just give us radius distances. So again, I hope this helped. Again, if you're watching at home, feel free to watch this again. If you know someone who needs some help, hey, forward them to these videos. That's going to be a good thing for them. Also, don't forget there are other videos about the other homework assignments, and there's also going to be videos posted in which I'm going to walk through each one of the proofs. In fact, that's what's coming next. So the next video in the series walking through the three proofs that you were assigned. So let's get to that.